So everybody can see my screen, hopefully. If you can't, just let me know. So first things first, I want you to make sure that you check eClass and make sure that you don't need to redo any midterms. I reopened everything so that if you want to get a better grade, go ahead and take care of that. That's fine by me. And then the next thing that I want you to make sure that you take care of is if you have a blank cell in the performance final, or you have like an EXC, or if you have like an IP or like any other like code in there other than a number grade, please make sure that you take care of that performance final. Like it should help your grade. So like help me help you by making sure you take care of that performance final. Okay. Another thing I did send out in the remind chat that finals are not optional. And that's what Ms. Jarrett said this morning or this afternoon. So please make sure that you take all your finals and communicate with your teachers about when you need to take the finals. Today was language arts and PE electives, which include like weight training and that kind of stuff. And then tomorrow is, I think it's just math. But again, I sent out that screenshot, so just take a look at that. Don't miss any of your finals, please. What did she say? Is it okay if we do other work after the test, or should we do it before the test? Are you talking about for my class specifically? Yeah. Okay. Most of the stuff is going to close tonight at midnight. So I would go ahead. Are you talking about the Unit 7 stuff, or are you talking about final exam? No, extra credit projects haven't gone in because I want to give you the most credit. So with that being said, I want you to take the midterms as many times as you can, and then I'm going to put that extra credit onto that. Does that make sense? Is the interim supposed to say excuse? Yes, it is. Since y'all didn't take the county interim, I have to put an EXC in there because the county sees that interim data, and that's where they pull it from. So you didn't do anything wrong. We just didn't take it. We were supposed to take it like March 13th. Well, we weren't in school. So you're good on that one. But I would prefer if you got like all of your midterms and any other missing work done today, so that tomorrow all you got to focus on is that final. Okay. And if we need to have a conversation, that's okay too. Okay. I'm going to go ahead and get started. I would, if you can, take a screenshot of this or take a picture of it. So these are the AKS that are going to be on your final exam. Okay, so these are the ones that you need to focus on the most. So don't just go looking at all of the review guides. I know I posted both. If you fail the final, will it hurt your grade because it's saying it can help you? What is saying it can help you? Fail the final, will it hurt your grade? It's not intended to hurt your grade. It's supposed to help your grade. I would highly suggest doing really well on your final. If you are in that borderline like fail range, make sure that you do well on that final. If you're in like the A-B range, I mean, wouldn't super worry about it, but you should take the final still. Like, don't miss out on it. Does it go for all classes? I would strongly suggest you doing well on all of your finals and just taking them seriously. A lot of teachers, and this is kind of me going rogue, a lot of teachers have mixed feelings about everything that's going on. I mean, we had a long discussion today about grading and all that kind of stuff. Most teachers are being compassionate, but with that being said, you need to show some effort. And I know that's kind of harsh in the sense of most of y'all have been doing your work. So can we not talk? You can talk. You can unmute yourself. That's fine. Just remember, I am recording. So just keep that in mind. But Leah, if you want to unmute yourself, that's okay.
Oh, no, I was just asking. Sorry.
No, you're good. But yeah, I mean, it's just kind of up to the teacher's discretion to a point. But I've always got y'all's best interest at heart in the sense of I'm always going to have your back and try to, as best as possible. If some of y'all noticed, some of your NTIs got replaced this week.
Yes, sir.
So with that being said, like, I didn't ask you to do anything. So remember, I'm trying to take care of it on my part. So do your best on your part so that I can help you, help me, help you. Okay, that's my goal. And we can talk about this in just a second. I want to make sure that we hit the important parts of this, and I kind of go through some problems so that you're ready for tomorrow, because I really want you to do well on this. Okay, so these AKS are the ones that you want to focus on. So 6, 8, 17. These are where all of the review guides are pulling from for each of those AKS. So you can go to those review guides and you can look at them. There are 18 questions on your final exam. Okay. It should not take you more than an hour. Keyword is should not. Okay. Please don't try to open it, walk away from it, and then come back. Don't do it. Make sure you got good internet connection. If you need to reset your router before you start, probably a good idea. Like, just make sure everything's good to go, because I want you to do well on it the first time. Okay. So any questions on how many questions? Any logistic questions about this?
Is the final on E-class or USA test prep?
It's on E-class. So it's going to be under quizzes, just like all of your tests have been. So you'll just go under there and I'll say final exam. And it's just one test. So you just sit down and you take it. That's it. Okay. All right. So I kind of want to hit a couple of these questions just so you kind of get a feel of what it should be like. Not going to lie, very similar to what you've been seeing throughout digital learning, in the sense of the types of questions that you've been getting. So just keep that in mind. So if you've seen previous AKS, like for instance, AKS 24, that's normal distribution type questions. Okay, so they're going to be kind of similar to what you've been seeing. Okay, so I'm just going to start going. And if we get to a point where you're like, I'm good, I need to go, that's fine. If you're like, I want to sit here throughout all of this, that's fine too. I would suggest writing some of these problems down because you might see something very, very similar. Okay. So this is AKS 17/20. So this is create and solve. So what you're going to do on this one is you're going to try to isolate the radical, which the radical is already isolated. So then we're going to square both sides. Yes, I am. It is going on YouTube. So I'm going to square both sides. And that's going to give me x squared minus x minus 1 equals 2x minus 3 times 2x minus 3. Then I'm going to multiply that other side out. So 2x times 2x gives me 2x squared. I'm trying to do this in like 35, maybe 40 minutes. That's the goal. So I'm going to try to like fly through this as quickly as I can. I'm going to multiply 2x times negative 3. I'm going to do negative 3 times 2x. Negative 3 times negative 3. So now what I'm going to do is I'm going to move everything to one side so that I can factor. Okay, so I'm going to subtract this x squared. If I can actually type. I'm going to subtract this x squared. And that's going to give me x squared over here. I'm going to add this x. That's going to give me negative 5x. I'm going to add 1. And also, don't forget this, negative 6x over here. We're going to combine like terms in just 1 second. So 9 plus 1 is going to give me 10. So negative 5x minus 6x is going to give me negative 11x. And now we're going to actually factor this. And this is the part where a lot of y'all struggle with. So what you're going to do is you're going to do the big X. You're going to do a times c. Yes, you can. So Alexis asked, can you combine like terms first? So negative 6x minus 6x, that'll give you negative 12x, plus x will give you negative 11x. So that's fine either way. So you're going to do the x, and you're going to do a times c. So 1 times 10, and that's going to give me 10. And so for my visual people, 1 times 10 will give me that. And then I'm going to take my b value and put it down here. That's okay too. You can do it that way. Sometimes it's just a little bit easier to do this because personally, I don't want to do the quadratic formula for negative 11 because I'll mess up the negatives. That's just me. But what I'm going to do is I'm going to find factors of 10. Okay, so factors of 10 would be like 1, 2, 5, and 10. Now, I need two factors that if I multiply them together, I get 10. But if I add them together, I get negative 11. Okay, well, 2 and 5 wouldn't work, right? Well, what about 1 and 10? Well, I can make both of those negative. So I can make negative 1 and negative 10. Okay, so I can rewrite this as x minus 1 and x minus 10. What are the 1, 2, 5, and 10? So those are factors of 10. So right here, all of these numbers came from factors, things that I can multiply together to give me 10. Okay. So now what I'm going to do is I'm going to set both of these equal to 0, and then I'm going to solve for x. So x minus 1, I'm going to set that equal to 0. If I solve for x, I'm going to get x equals 1. If I set x minus 10 equal to 0, I'm going to get x equals 10. So x can equal 10 or it can equal 1. Everybody okay so far? Okay. So what you're going to do, though, is you always want to make sure that your radicals check out. So what I mean by that is you take these two numbers and you plug them back in for these x's and make sure that both sides balance out. So we're going to do that for both of these. So if I take 10 and I plug it back into this equation, I'm going to get the square root of 10 squared minus 10 minus 1. Well, 10 squared is 100. 100 minus 10 is 90. 90 minus 1 is 89. Well, what's the square root of 89? Some number, right? Like it's going to be 9 point something something. Okay, so we've got 9 point something something on this side. On the other side, if I plug in 10 here, 2 times 10 is going to give me 20. 20 minus 3 is going to give me 17. Does 9 point something something equal 17? No, so technically 10 is not an answer. I'm going to let that sit in for a second. I know I'm moving pretty quick.
What do you mean 10 is not an answer?
So when I plugged it back into this equation, it doesn't work. So both sides don't balance out because like 9 doesn't equal 17. So when I plugged in 10, I got 9 point something over here and 17 over here. Well, that doesn't balance out, right? So 10 wouldn't be an answer. Let's try plugging in 1. And I'm going to clear a little bit of this so that you can actually see it. Okay, so we're taking the original equation right here. And we're plugging in 1. So I'm taking the square root of 1 squared minus 1 equals 2 times 1 minus 3. Okay, so I plugged in 1 for every x up here. 1 squared is 1. 1 minus 1 is 0. And 0 minus 1 is negative 1, right?
Right.
So we've got the square root of negative 1 on this side. Over here, we've got 2 times 1 is 2. 2 minus 3 is negative 1. My question to you is the square root of -1 equal to -1?
No.
It's not. So 1 is also not an answer. So this has no real solution. With me on that.
About this one. So you trying to see the numbers match up. I forgot this whole thing. Okay. Got it.
Yeah. It's been a hot minute since we've seen these.
Yeah.
Mm-hmm. This was like Unit 4C, so this was like January, February. It's been like a minute. Are we okay on these?
Yes.
And there's a couple other ones on that review guide, so if you want to go in and practice, and remember those answer keys are already posted too, so like if you want to check your work, probably a good idea. Okay. Oh, there's the car. Okay. All right, so I'm going to go ahead and go to the next one. Okay, so the next AKS is 34th/35. A lot of you, I love you dearly, did not do well on this AKS. And it's solely because you either A, don't know how to put it into your graphing calculator, or B, don't just user error, I guess. Okay, so on this one, all you got to do is identify which graph is this function. So if you've got your graphing calculator, all you're going to do is type this into your graphing calculator. I want everybody to try to plug this into your graphing calculator. Okay, and we're going to see if we get the same thing. So take a moment and plug that function into your graphing calculator so that we can see if you understand how to plug it into your graphing calculator. Or you can use Desmos. That's an option too. I'm going to give you a second to like locate it if you need to. So again, AKS 34 is really just like graphing.
Can we use TI-83 calculator for that? Okay.
I would. It's probably going to be the easiest way to do this. That would probably be my suggestion. That's what I use. If you're on a laptop, you can go to like type into Google and just do TI-83 download, and it'll pull up a free download. So you're typing this
line.
What's up, baby?
It made a straight line on the.
Okay, I'm gonna post what I got in just 1 second. Make sure you put that negative next to your X, and don't use the subtraction. Use the negative.
Well, you probably gonna get it right. I did that, but I don't know.
That's okay. So it should look roughly. So hit Y equals 9. So it should look roughly like that.
Yeah, I got that.
Yeah, I got that.
I got that.
Good.
Yeah.
Right, if you hit that zoom button, you can zoom in and you can actually like see it a little bit better. I know sometimes on like E-class it's kind of difficult to like see what the function actually looks like. So if you ever are questioning it, I always go to my table by hitting second graph. I pull up my table and then I plot those points. And so I just check and make sure that way. That's just a quick way to check. Try plugging in that second one into your calculator. So you're typing into your calculator, you're hitting Y equals, and then you're going to hit -4, second X squared, X plus 1. Make sure you close those parentheses too.
Those parentheses.
Yeah, it should look like. It should look like that. Is Desmos a good alternative? Yes.
Okay.
You can use Desmos. Sometimes it's a little tricky to type in, so just try to practice a little bit with it before you take the final. Does that make sense?
Is the finals timed or like what is it?
You should only take like an hour to do it, but I think I gave y'all a little bit more than that. I'm pretty sure I put like 3 hours, but I think I might be speaking out of terms. I think it might be 2. Okay, so if you put that into your graphing calculator,
It made a curve, kind of a little bit curve.
Yeah, it's got like a dip going down, right?
Yeah.
Like whoop. Okay. If you did not get this, make sure that you plugged it in correctly, and make sure you put parentheses and make sure that negative sign, because it does depend on that. It's open from 7 to midnight, right? It's open from 5 a.m. to 5 a.m. So 5 a.m. tomorrow to 5 a.m. Wednesday. Yeah, Wednesday. Sorry, I forgot what day of the week it is. Quarantine life, it's hard. All right. So are we okay on 34?
Yeah.
Okay. Okay, so 16, 17. So this is, it's really predominantly called AKS 17. So this is, I think it's creating equations or something like that, or identifying the equations. So in this one, it says you've earned $500 mowing lawns over the summer. How long will it take you to double your money, if you keep it in an account earning 6.33% compounded continuously? So we're going to use this formula. We're going to use PERT formula, and we're going to plug in. So that P is going to be our initial amount. That's going to be our 500. E is, remember, it's kind of like pi, or but it's 2.718 if I'm not mistaken. And then R is going to be our rate. So our rate is 6.33%. We always want to change percent to decimal. So we're going to move 2 decimal places over. So it's going to be 0.0633. And then T is going to be time. So we're trying to figure out how much time, right? So we're going to solve for T, but we're going to set this equal to some number. Well, what's the only other number that we've got? Well, remember how it says, how long will it take you to double your money? Yeah. So what's double of 500?
1,000.
Right? Yep. So what is 2.7? So that's the E. So like if you went into your calculator and you typed, second ln 1 and hit enter, that's going to be your E value. It's like an inverse for common log. Yeah, that's probably the best way to explain it. I can go in detail, but it would bore you. So I'm not going to. All right, so what you got to do now is you actually got to solve this. Now, here's the tricky part. You're going to have to use the fact that you have that inverse logs. So like logs and exponentials are inverses of each other, right? So the first thing you want to do on this problem is you want to divide by 500. Okay? And when you do that, you're going to get 2 equals e to the 0.0633t. That looks like a hot mess. Now, how do we get rid of e?
ln.
ln. Okay, so we're going to take the ln of both sides, and that's going to cancel out that e on the right-hand side, and it's going to bring that exponent down. Okay, so we're going to take the ln of both sides. These are going to cancel out, and I'm going to bring this down here. I'm sorry. So this is going to give me ln of 2 equals 0.0633t. ln is the log. It's the natural log. It's, so you know how we have log that's written out like this? That's in base 10. So ln is in base e. So really it's like log of e. And the way that we can rewrite this is by ln. These are the same thing. Log of e in base e is the same thing as ln. Yeah, okay. And I'm going to erase that. Okay, so now what we're going to do is we're going to divide by 0.0633 on both sides. Divide by 0.0633 on both sides. My handwriting has gotten progressively worse. We're going to put this into our calculator. I blame Corona, man. I was doing so well. So I'm going to divide this in my calculator. And it's going to look like this when I put it in my calculator. that second line that you're going to see. So that line down at the bottom, and that's going to give me time equals roughly 10.95 years. Yeah. So roughly 11 years. It's going to take me 11 years to double my money for one summer. That sucks. Just a little bit. All right. Questions over this? Okay.
No.
Okay. Is it okay if I erase the bottom half so we can work on that second problem?
Yeah.
Okay. Okay, so the other aspect of AKS 17 is the fact that you're going to have to write equations, write a system of equations, and then you're going to have to, you won't have to solve it, but you have to explain what it means. Okay, so for instance, it says the coins that Alexis has are dimes and quarters. Her coins have a total of $5.80. She has a total of 40 coins. Write a system of equations that can be used to find the number of dimes, D, and the number of quarters Alexis has. Explain your choice. So, first things first. I've got these dimes, and I got these quarters. How much are dimes worth?
0.1.
10 cents or
0.110.
0.1, right? Yeah, 0.10. Okay, how much are quarters worth?
0.5.
0.25.
Right, okay.
0.25.
So, what I've got is I've got a total of 40 coins. So the number of dimes plus the number of quarters equals 40 coins together, right? And then y'all told me that the value of each of these is 0.1 per dime and then 0.25 per quarter. Well, how much does she got in total? 580. And yes, you could have used D and, oh, I used this. You're good. So explain your choice. Well, I mean, that's how you do it. So, what does it say? Explain your choice. That can be used to find. Okay, so I could solve for one of these variables, and then I could plug in to solve for the other one, like to solve for the number of dimes and quarters, but it doesn't ask us to do it. It just says to write a system, right?
Mm-hmm.
So technically we're done. Okay. Questions over this? Okay. All right. AKS 8. Yay. All right. So it's finally made an ugly appearance because it wasn't on a test, but you did have a quiz over it. Okay. And hopefully this is easy because you're going to need these two formulas. Write these formulas down. Okay. Write them down. Like put them on a piece of paper, put them on a cheat sheet, whatever you got to do. This is AKS 8. Write these two formulas down, the one in the red and then the one right here too. Okay. So you got the recursive and you got the explicit. You got to have both. Okay. So first thing we want to do is we need to identify what all of these random things mean, right? Okay. So R is going to be your rate, and A sub n is going to be like, n is the term that you're trying to find. Okay, so to find the next term of the sequence. Okay, so for instance, we're going to find the rate by taking the second term and dividing it by the first term. So you find the rate by taking the second term and dividing it by the first term. So that's going to be 15 divided by 3. So that's going to give me 5, right? Hopefully we can do that quick math, right? Okay. So now I've got A sub n equals 5 times A sub n minus 1. So what that means is I'm going to take the previous term and multiply it by the rate. So we're trying to find the next term, right? So that means I'm going to take 375 and multiply it by 5. Okay, so I'm going to take 375 and multiply it times 5. So I'm going to go into my handy-dandy calculator. Y'all ever watch Blue's Clues? That's what I feel like right now. It's like my handy-dandy calculator. So I'm going to get 1875, right? Sorry. All right. Questions over this. So I use the previous term and the rate to find my next term. And this is how I write it out, right?
Can you go over it one more time?
Okay, so the first thing you want to do is you find your rate. So you're going to take your second term and divide it by your first term. So that's going to give me that 5. And it wants me to find what the next term of the sequence below is. So I went 3, 15, 75, right? So I'm multiplying by 5 each time. So times 5, times 5, times 5. So to get the next term, I'm going to multiply by 5. And so that's really what this formula is just saying. It's saying take this next term or this previous term, multiply by 5 to get you the next term. Okay. All right. So number 2. Leah, are you texting someone?
I'm sorry. No, I was tapping my finger just to figure it out. I'm sorry.
Okay, you're good. Okay, so number 2, it says write the recursive rule to find the next term of the sequence. Okay, so you're going to take a sub n, and we got to find our rate. So that means we're going to take the second term and divide it by the first term. So 16 divided by 4, and that's going to give us 4. And we're going to say a sub n minus 1. So in order to find the next term, I'm going to take this term right here, which is 256, and I'm going to multiply it times 4. I'm going to go into my calculator because I don't know what 256 times 4 is. I mean, I could probably figure it out, but it's 1024. What is a sub n minus 1 do? Okay, so this a sub n minus 1 is just saying whatever term you're trying to find, which is this 1024, you're going to take the previous term, which is 256, and multiply it times 4. A sub n minus 1 means the previous term. Does that make sense? Okay. All right, cool. Okay. So now that we've got recursive formula, which means that we essentially go back in time and use the previous term to get us the next term. Now we're going to write the explicit formula, which is what our brain normally works in. Okay, so we get rid of this a sub n minus 1. What was the first one recursive formula 2? Yes, these two were recursive. And then now we're going to do explicit. Okay, so what I'm going to do is I'm going to write the explicit rule to find the nth term of the sequence below. Basically, this is a fancy way of saying, hey, write the equation for this. Okay, that's basically what this is saying. So in this formula, you've got this a sub 1. A sub 1 is always your first term. Well, what's the first term in this sequence? 3. So we're going to plug 3 in for that a sub 1. And then we're going to figure out what our r is. And again, we're going to take the second term and divide it by the first term. So 15 divided by 3, which is going to give me 5. And I'm going to raise that to the n minus 1 power. Okay. So if I wanted to find like the 15th term, I would plug in 15n for this n value. Okay. I could not use, I couldn't find the 15th term using the recursive formula. Does anybody know why I couldn't use the recursive formula to find the 15th term right now? Or why it would take me such a long time to use the recursive formula?
Is it only used to find the next one?
Yeah.
Okay.
Yes. Okay. So, huh? I gotta.
So you have to keep multiplying.
Yeah, you have to keep multiplying. Like I would have to figure out what the 14th term is in order to figure out the 15th term, right? So I'd have to sit there. I'm not doing that, right? So I can use the explicit rule to help me, and that would be a much more efficient way to do it. And again, this is how our brain normally works. You're gonna write me an equation that actually works rather than use the previous term. Anybody got time for that? Questions over AKS 8? Okay. Okay, AKS 42 and 46. I know y'all love these. So with this one, the one thing that sucks about this AKS is it can ask you about max min values. It can ask you about greatest root. It can ask you about the y-intercept, the x-intercept. Like, it can ask you about multiple key features. So that's the one thing that's terrible about this. So I'm going to hit the two main ones, but you need to make sure that you understand all types of key features. So if you have no idea what I'm talking about, like if I'm using words that you don't understand, you got some work to do, okay? So compare the function shown in the graph below A. Okay, so this is A. And then this is the function, which is B. Okay, which function has the greatest maximum value? Okay, so we're looking at the y part of the vertex. Y part of the vertex. That's what this is saying. Okay, now what is a vertex? The vertex is the maximum point. Okay, so for instance, on this graph of doom, oh, I gotta squint. It's right here. Okay, and that's roughly like 9 point something, right? That's the y value right here. 9 point something, right? Because I can't tell. It's like 9.25. Okay. Now, for my function though, way back in algebra 1, okay, your teacher taught you a formula. Or what you could do is plug it into your graphing calculator and look at the graph, because that would be the smart thing to do. Okay, so I can show you the formula, or we can put it in the graphing calculator. I'm going to show you the graphing calculator because it's going to be easier. So when we plug this into that y equals button, we're going to plug this into our y equals button. We're going to type this.
Greater.
Say it again.
The graph is greater.
Girl, we almost there. Calm yourself. Fine. Okay.
I did it.
You already did it? You done did it. Okay, so we're looking at the y values though. So are you sure?
Now you got me questioning me, and I gotta
If it goes past 9, then it's higher.
right.
Okay, why?
So I'm gonna show you what the table looks like really quick for this equation. So like if I type this into my calculator and I hit table or second graph, this pulls up the table. Are these y values bigger than 9 point something?
Yeah.
Okay, so which one has a greater maximum value?
The y equals negative x squared.
So in this instance, I would say B is greater because bigger y value, right?
You go based off the table. You don't go based off the graph.
You can go based off of the graph as well. Like when I look at this, I had to zoom out. Hold on, let me zoom back in so I can show you. So like this is a 10 by 10 window right here. This is what, if you type this into your graphing calculator, this is what it looked like. It looked like a hot mess right there, right? Okay, this is a 10 by 10 window. So that means that the maximum is all the way up here. So it's like way off of this table or this graph window. Does that make sense?
Yeah.
Okay, you're saying yeah, but
it's like I did the graph, it gave me a different answer. So now you did the table, you can actually see the numbers that is greater than like function A. So I don't know, but
so
that way.
Did you plug it into your graphing calculator correctly?
Yes, and then I pressed the graph and I got that it was lower than the x-intercept. Well, not intercept, the y, the greatest maximum value. So I don't know.
Are you sure you put that negative out front, or is it facing the other way?
I put it in the front.
Did you put a negative instead of a subtraction sign?
We're talking about from like negative x squared minus 8x?
Mm-hmm.
Yeah, I put it right. Yeah, because I have
You get the
negative.
same table. So hit second graph and see if you get the same table. And scroll up to like -4 so you can check yours.
Well, I'm not getting positive numbers, but I'm getting negative numbers.
Okay.
Maybe
So if you're
it's
getting
graph my phone. I don't know.
if you're getting negative numbers, then something's wrong with
Oh,
your.
I got it.
You got it? Okay. Do you see it now?
Yeah, I see it.
Okay. So because those y values are bigger, then b is going to be the greatest maximum value. Okay. Chloe, did I answer your question, babe? I know this one's confusing because it's like it's a lot. All right, we ready to move on to that next one? It's kind of similar on the next one, except now we're talking about greatest roots, which is also known as, and I need like if you leave my classroom, I need you to know that greatest roots, I'm yelling, I'm sorry, are x-intercepts.
Yeah, x-intercept. Oh, okay.
Like I need you to know that, okay? So greatest roots means x-intercepts. And when it says greatest, it means largest number. So for instance, on this, sorry, I'm getting heated. It's fine. All right, so for instance, on this graph right here, we're looking at the x values. Okay, so right here, it's got like negative like 0.5. Homegirl's blind. I can't see this graph. All right, so then you've got this other one that's like right here. That's like positive, like 5.5. Okay, and now we got to look at our joker that's in the the graphing calculator. So if I'm looking at my graph, because these are not the same functions. Ooh, they're not the same functions. Did you notice that?
Yeah.
Anybody catch that? Okay, so when I plug this into my graphing calculator, I switch those negatives and positives because, I'm awesome like that. And then let me live my life. It's fine. Okay, so then what you're going to do is you're going to look at what the x-intercept is for that graph. And this guy right here looks like this. And
Yeah, I got that too.
Like I can't really tell what that is. So what I do personally is, listen, I'm blind. So when I have something that I can't really tell exactly like where it's touching, I go and hit that second graph and it pulls up my table. So hit second graph and pull up your table. And your table is going to look like this mess right here. Oh, somebody asked a question and I didn't see it. Pause. Okay, so wait, so graph has a higher maximum. On that first one, no, the equation has a higher maximum. Equation has a higher maximum because those numbers for the y values are bigger. For the next one, though, what we're looking at is, you see how on here, I like these tools. Okay, you see how it has this 4,0 right here?
Mm-hmm.
Okay, x-intercepts have a y value of 0. X-intercepts have a y value of 0. You're going to be hearing me tomorrow saying this. X-intercepts have a y value of 0. Okay, so with that being said, 4 versus 5.5. Which one's bigger?
5.5.
5.5. So which one has a greater root?
That
A.
Function.
Oh.
Miss Emmons,
What you want?
can I see how you typed it in the calculator? The second one.
Yeah. Give me 1 sec. Okay, there is a negative that's out front. It's just being blocked by the little like black piece.
Okay.
The little blinking light. It looks like that.
It didn't show me that, but I got the same answer, but it didn't show me that exact answer that you got. But maybe I'll put it in wrong.
You mean the table?
The graph. Yeah, and the table, both of them.
Okay. Make sure that you hit that negative button down at the bottom, not the subtraction.
Okay.
Like next to that decimal point, because that does make a difference.
Okay.
Cool?
Mm-hmm.
Okay. All right. We're getting there. We're getting there. All right. This is AKS 19/18. So this is constraint functions, and I know like y'all hate these. So with that being said, you really just have to identify what your variables are, the objective functions, and the constraints. Okay. Constraints mean restrictions. That's all it means. Okay. So it says the relationship between the quantity of shrimp and the quantity of lobster is shrimp costs $3.87 and lobster costs $7.47. And you have budgeted $120 to spend on these items for dinner. You can purchase at least 10 kilograms of shrimp and at most 20 kilograms. You can purchase at least 4 kilograms of lobster and at most 14 kilograms. Okay, so here's the deal. You got $120 to spend. Shrimp costs $3.87. Lobster costs $7.47. Let's write an equation using those. But first, we're gonna name these guys. X is gonna be shrimp, because I don't want to write S. X is gonna be shrimp, and Y is gonna be lobster. Okay, and you can put pounds if you want, or the kilograms if you want. That's okay. The objective function is normally deals with like money or like I don't have another instance. We'll say that number 2. But normally it's dealing with money. So for instance, it's going to cost $3.87 for shrimp and $7.47 for a lobster. And we're going to set that equal to $120 because your girl isn't spending more than $120, right? Okay. That's the objective function right there. Now, there are constraints because it told us like all this mess down here where it's like at least 10 kilograms and at most 20, right? On your performance final, it had that, it had something like X is bigger than 0. It had X is less than like 10, right? So these are constraints. That's what it's talking about. It's having that restriction on that variable. That's what they're saying right here. So you can have at least 10 kilograms and at most 20 kilograms. And I am doing the line underneath because that is inclusive. Okay, so how would I write it for the lobster part? I would write it
the same way.
Yeah.
Same. Yeah.
Right. Yes. Okay, so the same way, except now you're using Y and you're using the different numbers that they gave you, right?
Yeah.
Okay. Now, I wrote that as a compound inequality. One thing that I want to mention is that you could write these in separate. So really, like, you could write this out as Y is bigger than or equal to 4 and Y is less than or equal to 14. These are the same things. Okay, so I really want you to see both of those because sometimes y'all get tripped up on which way the alligator's facing, and I get that. Okay, so just keep that in mind that these are the same things. Okay, questions on that? All right, we're almost there. We're getting there. We're getting there. And again, if you need to go, that's fine. I am recording this, so I will post it in just a second. The relationship between the time spent walking and driving is if you walk at 3 miles per hour, then hitch a ride in a car traveling at 40 miles per hour, covering a total distance of 50 miles, you walk 2 to 4 hours, and your ride a car. That's not English. You ride a car for at least 30 minutes and up to an hour. Okay, so first thing I want to do is I'll identify my variables. So my variables are W is going to represent the walking, and D is going to represent the driving, right? And you can use whatever variables, it doesn't matter, just identify them. Okay, now we're going to write a objective function. So we're doing 3 miles per hour walking. Okay, and then we've got 40 miles per hour driving. for a total distance of 50 miles, right? Okay. So then it says you walk between 2 to 4 hours and you're in a car for 30 minutes up to an hour. So let's talk about the walking first. So walking is going to happen in between 2 to 4 hours. And the reason why I didn't include the line underneath is because it was between 2 to 4 hours. Like it doesn't say including 2 to 4 hours. Like it doesn't say at least or anything like that. That's just how I interpret it. Normally you won't have to worry about that too much on this. Okay. With the driving though, it says 30 minutes to an hour. Okay. I've got to make sure that everything is in the same units. So this 30 minutes, how can I convert that to hours? 30 minutes is how much of an hour?
Half.
Right, which is represented by 0.5. Okay, so at 0.5 up to 1. So again, we've got to make sure that I've got minutes and hours. I got to have the same units, right? Okay. Questions on this? Okay. AKS 24. This is the one that y'all did not like. This is the one that we, it was on the last test. And a lot of y'all were like, I don't know what's going on. I'm going to go over it really quick.
Okay.
I studied this. Say what?
I studied this. I did not get it.
Okay. That's okay. We're going to go over it. Okay, so I'm going to give you a crash course on it. So, normal distribution. Okay, so it says given an approximate normal distribution with a mean of 121. First thing I'm going to do is I'm going to put 121 in this middle part. Okay, so on your paper, when you get these types of questions, you're going to draw a curve and straight down the middle, you're going to put whatever the mean is. Cool? That's the first thing you're going to do. Next thing you're going to do is you're going to draw 2 lines on either side. They do not have to be perfect unless you're a perfectionist, and it's fine, like me, because that line is so straight. Okay, so what you're going to do is you're going to take whatever the standard deviation is. Okay, so standard deviation is 40, and my mean was 121. Guys, you got to know these 2 symbols. You got to know them, okay? Like, don't be asking me, hey, what this? No. Okay.
What's the data point?
What's the data point?
Yeah. Does the I'm going from the equation. The z equals data point minus mean divided
You're
by
talking about z-score. We ain't even there yet, girl.
Oh,
we're not
wow.
there yet. Yeah, we're not there. We're not there. We're getting there. Not yet there. Okay, so now what you're going to do is you're going to take 121. You're going to add 40 to it. Okay, so you're going to take your mean and add the standard deviation. So that's going to give me 161. And then you're going to take the mean and you're going to subtract 40. So 121 minus 40 is going to give me 81. Yeah, I can do math. Quick math. Okay? It's been a long day. All right, so then you're going to do another standard deviation. So you're going to add another line that's going to be super straight because, you know, you're a perfectionist. And you're going to add 40 to that side and then subtract 40 to the other side. So 161 plus 40 is going to give me 201. And then 81 minus 40 is going to give me 41. Everybody with me so far? Sort of, kind of.
Yes.
Okay. And then you're going to draw one more line because you're just like a gangster. It's fine. Okay. You're going to add these lines right here. And you're going to add 40 to one side. And then you're going to subtract 40 from the other side. So 201 plus 40 is going to give me 241. I can do that one. And then 41 minus 40 is going to give me 1. All right. So we've got this hot mess of a curve on our paper. So you see how they say label 1, 2, and 3 standard deviations?
Yeah.
Okay. So here's the deal. All of this mess. Oh my God, I got this color coordinated. It's going to be beautiful. All right. So all of this mess. I'm excited. All right. The first line that you drew, that's in your first standard deviation. So that's represented by just like a little sigma right there. Okay. And if you're going into fraternities or sororities in college, you need to know these different Greek letters. It'll save your life. It's fine. Okay. So you got a sigma, right? Okay. Then if you go over just a little bit more into this little next section, oh, I should have done that blue. I messed up. No. Sorry. Colors give me joy. Just let me have it. Okay. So if you go into that next one, then that is 2 standard deviations away from the mean. So that's 2 sigma. Right?
Yeah.
Okay. If you go another standard deviation over.
No, I don't.
What?
I don't get it. What do you mean 2 sigma?
So that's 2 standard deviations away from the mean. So from this like center point right here, you're messing up my color. Okay, from the middle point, you're going 2 sections over, like 2 lines over.
Oh, okay.
Yeah. Okay, so then if you go 3 lines over, you got this 3 sigma. Yeah.
Yeah.
Okay. Now here's the part that blows everybody's mind. Remember, or if you were with me, you were supposed to memorize the percentages. Please, if you don't want to memorize it, write it on a piece of paper. It's okay. Okay. So,
These?
Right? No, the percentages that go in
34 and then 13. Yeah.
Okay. So 34, she's talking about these numbers right here. 34 goes in these first standard deviations. In the next standard deviation, it's 13.5. My handwriting starts getting really bad as it gets smaller. And then the next one's 2.35. Listen, it's just a struggle. And then you got that 0.15 that's on the real far outside. Ooh.
That was 2.5.
2.35 and then 0.15.
Oh, I thought it was 3.5.
I got lost with the percentages.
So you got that from the Z-score chart?
No, we're not even talking about Z-score. No Z-score. Not yet. Not even
That's empirical rule.
Yeah, she knows. Oh,
what's the difference between this and Z-score?
Okay, so Z-score is if it doesn't follow, like if it doesn't fall in this natural normal distribution. I'm about to go over that Z-score in just a second. I want you to get these 3 things because you're gonna be asked over these 3 things. For
so
sure.
What are you doing for this? Like,
you ever heard of a bell curve?
Bell curve, yes, I've heard of a bell curve.
Okay, so when you take your test, sometimes your teachers put you on a bell curve. So that means that your average normally falls around roughly a 70, right? So majority of your class roughly falls in that 70 section. So that's that 34%, right?
Right.
And then you got a couple more people who got like B's. You got a couple people who got like C's and D's, right? So that's at 13.5%. And then those outliers, like the farther out you go, that's going to be your A group. And then that's going to be like your failing group, right?
Right.
So this is just representing the natural normal distribution that occurs, that should occur in statistics, okay? Z-score helps us find stuff that doesn't fall in these specific standard deviations, which again, we're going to go over that in just 1 second, okay?
Okay.
You need to remember those numbers. Write them down on a piece of paper. Write them down on a piece of paper. Save that paper for tomorrow, though, okay? All right, so on question B, it says, what interval contains 68% of the data? So you always start from the mean, okay? So what's 34 plus 34?
68.
So, and it said, what interval contains it? So you're going to include the numbers that is from the bottom part to the top part. So for these red things, like these red sections, you're going to go from 81 to 161. So I'm writing 81 to 161. Okay? With me?
No.
Okay. So 1 standard deviation away. You see that 34% on both sides?
Yes. I see.
What's 34 plus 34?
Got me thinking now.
68.
It's 68, right? And what did our question ask? It said, what interval contains 68% of the data?
So we gotta add.
Interval is a number, right? The number.
Interval, yeah, interval's a number. What was your question?
I said we have to add to find the percentage for the data. Like you just did. Like you said 34 plus 34, 68.
That gets you 68% of the data. Yeah.
Oh, you're saying the numbers between the. Oh, okay, I got it. Got it.
Okay. 95% of the data. So that means that we're going from the mean and we're going to go out and we're covering 95% of the data. So 95% of the data is going to, I'm going to mess up my colors, is going to include from here all the way to, that's not math.
What?
Is that right? Hold on, let me add that. So I've got 68 plus, ooh, calculator's tweaking. Okay, so I've got 13.5 plus the 34 plus the 34 plus the 13.5. So that's like 2 standard deviations from the mean. We always go from the mean, okay? Now it's asking what is the interval that contains 95% of the data. So from my yellow marks right here, what's my lowest number?
41.
What's my highest number?
201.
Right.
No, 161.
Not 201.
It was 201? Okay, 201.
Okay, so you go from 41 to 201. With me so far? It's okay to say no.
I just want you to get to the letter D because it's not a percentage on there. So
what interval
that's
contains?
the hardest one.
So you're adding.
Say it again.
So you're adding the yellow to the yellow, and getting the same percentage.
We're getting 95% of our.
Well, how do you know when? I mean, how do you know where to go ahead and add to get the data?
How do you know?
Like you're saying, like you said 34 plus 34, that's 68. Like how do you know what numbers to use to get the percentage?
So you see how we went from 34 to 34? Look at our interval numbers that are below that. You see where those crazy lines that I drew?
Yeah.
Right now. Okay, what number is below it?
81.
To 161. And so that's why we wrote that interval down.
Oh.
Does that help?
Yes, a little bit.
Okay. All right. On D, I'm going to make sure I tell you all this right. Okay. So on D, it says, what interval contains 97.7% of the data? This one's a little tricky, just a little bit, because if I do the next interval over, so that means we go from here, we go farther out one more. That's going to put us at 99.7%, right? So I really wouldn't worry about this one. I think this was a typo. I think they meant to put 99.7 because you're not going to have to calculate this. So I'm going to say this is 99.7% of the data. And what's the interval for that? Because otherwise this isn't talking about the empirical rule. Does that make sense? Because the focus is trying to look at the normal distribution. Okay, so with that being said, I would go one more standard deviation over, and that would include 1 to 241. I can read my handwriting. 1 to 241. Okay, so we're changing that to 99.7, and we're saying from 1 to 241. Now, z-score would be if I wanted to calculate some type of interval, like let's say I wanted to find the percentage between, so z-score would be like if I wanted to find from, let's say 91 to 141. That is when you would use that crazy equation. So you would do z-score equals, somebody read it to me. I never remember this one. Y'all probably don't have it in front of you, but it's like standard deviation over whatever number. I'll pull up that equation in just 1 second. I would have that one written down as well, just in case.
Is it the one when it's like between those numbers? That type of question?
Yes. So like if it was like from 91 to 141, that's like finding in between here and here. Right? That is an awful script.
That is hard.
Okay, but like it would be finding between those two, right?
Okay.
I don't think I included one on here. Nope, I didn't. If we need to go over more z-score, we can. But I'll have to pull some questions for that. I don't know why I didn't pull it in the first place. Are we okay on this normal distribution? Because you're going to be asked these three for sure. Data point minus mean.
Yeah, that equation.
There you go. Data point minus mean over the standard deviation, right?
Mm-hmm.
Okay. So let's actually calculate this one. Can I erase the insanity that is below? Can I erase B, C, D? Can I erase all of that so that you have space? Okay, so that you can actually see what I'm doing. Let's say that I wanted to find, we're just doing a for instance. Let's say I wanted to find 91 to 141 for the interval here, okay? I wanted to find the percentage for that. So what I'm going to do is I'm going to take 91 and I'm going to subtract the mean. So the mean is 121. I'm going to divide it by our standard deviation of 40. Okay, so I'm going to go into my calculator and I'm going to say 91 minus 121, and then I'm going to divide it by 40. And that's going to give me negative 0.75. I'm going to go into the negative z-score table and pull the z-score number. Make sense?
Mm-hmm.
Yeah, I got that part now.
That part, no?
No, I got that part. Like going to the Z.
Okay. So if somebody can do me a favor and pull the z-score number for that. I thought it was 141. No, we're going from 91 to 141. So we're not done yet. We haven't answered the question yet. Okay.
I got negative 0.7.
For the z-score?
Oh, 0.2266.
2266. Okay, so this is the z-score for 91, right?
Oh.
Is that what? Are you good, Leah?
Yeah.
Okay, did you do it right?
So we're trying to find.
You're trying to find the z-score for, or the probability for negative 0.75. So you're going to that table and you're going to go into the negative z-score table and go negative 0.7 and then go over to 0.05.
Yeah, and I got 0.2266.
Okay, cool. All right, so then now what we're going to do is we're going to find 141 z-score. Okay, so we did all of that mess for 91. Now we're going to do it for 141. So we got 141 minus your mean, which is 121, divided by 40. Again, going into my calculator of doom, divided by 40. That's going to be like 0.5. Yeah, 0.5. So I'm going to go into the positive z-score. And I'm going to say 0.5. Tell me what the number is.
0.6915.
Okay, so what you're going to do now is, now that you've found what 141 z-score is and 0.226, 91 z-score percentage, you're going to subtract those two because you're trying to find the interval that's in between those two. So I'm going to go into my calculator and I'm going to type 0.6915 minus 0.2266. And that's going to give me a whopping 46.49%. Now, I need you to bear with me on this. Remember how we talked about 34% for each side for the first standard deviation and how that's 68% of our data.
Mm-hmm.
And we just narrowed our interval, right? We just made it smaller, right?
All right.
Mm-hmm.
So 46.49% is inside of 68%. So that makes sense, right?
Yes.
Yeah.
Okay, so I just want you to make sure that when you get these answer choices, you really kind of think about, oh, does this make sense? Okay, so just keep that in mind as you're doing these problems. Does that help a little bit?
Miss Emmons,
Yes, ma'am.
I know how to do the z-score. I just don't know when you do the -1.
Yeah, that.
I don't know when to do that.
The -1.
Okay, can I erase this really quick?
Yeah.
Yes, you
I
can raise.
screenshot it.
She's like, no, I didn't write anything down. Not happening. I'm just kidding. Sorry. All right, so ooh, I don't know how y'all put up with me. I'm so sorry. Okay, so if everything is taken from the left, okay? And what I mean by that is if it says at most 161, okay? You're not going to do the 1 minus, okay? If it says at least, if it says at least 161, that's talking about this mess to the right of 161, okay? So at least means to the right of 161. That is when you're going to do the 1 minus. So if they use the term at least 1 minus. Does that help?
Okay. Yeah.
Yeah, I would look for that phrase. Okay. My dog has just passed out. He's like, oh, tired. Okay. What was at most? At most is just regular. You're going to use the z-score table, just like you normally would. You're not going to do anything. At least you're going to do the 1 minus. Okay. We are going on an hour. I'm so sorry.
It's okay.
I'm so sorry. We're like almost there. That's a lot of information to cover. Okay, so AKS 51, y'all are pretty good about this one. So I'm not gonna spend like a whole lot of time on it. This is going back to the inverse. So going from logs to exponential, and exponential to logs. So it's going back and forth. I broke this down step by step though. Obviously on your final, it's not going to ask you step by step. It's just going to say, which one of these is the exponential? So it's kind of just like, what's your final answer? So in this case, though, we're going from exponential to log form. That's what we're going to do. So they want us to solve for m. That means get m by itself, right? Okay. So the first thing that we're going to do is we're going to divide by 50 on both sides because we're taking this equation and we're going to solve for m. So we're going to divide by 50 on both sides. So that's going to give me b divided by 50 equals 16 m divided by 12. Oh my gosh. Why is this handwriting so awful? Oh. Okay. So that's the first thing you're going to do. Then in order to get it out of exponential form, we're going to use the circle of life. Okay. I don't think I have anybody who's not in my class. So the circle of life, you're going to start at your base, go to your outside, and finish at your exponent. Go from your base, outside, exponent. So that's going to be log of base 16 of b divided by 50 equals m divided by 12. And then step 3 is you're going to multiply both sides by 12 because you're wanting to get m by itself. So this is going to be 12 log of 16 of b divided by 50 equals m. Sorry. Okay. My bad. Okay, so after you do the circle of life, you're just trying to get m by itself. So you're going to multiply by 12 on both sides. Okay, So your final answer is in that step 3. So again, divide by 50 on both sides, take the log of both sides to get it from exponential to log form, and then multiply by 12 on both sides. Questions on that?
Nope. So you don't solve with the 12 log 16?
No, because you don't know what b is.
Okay.
Yeah. It didn't give us what b was.
Okay.
And all it says was to rewrite. Is that what the final answer looks like? Yes. That's what the answer looks like. It still looks like a question, right? Again, it didn't give us like details. They just try to trick you on this kind of stuff just because like they try to confuse you with the 2 variables, but you just wanted to get m by itself. That's all you wanted to do. Okay. Now, if they gave us what b was, then we can like solve, but like it doesn't work. Okay. All right. Last one. Hang in there. Almost done. All right. Rewrite the function to find c of t. So this looks like a hot mess.
That's gross.
Right? Not fun. Okay. So what you want to do is you want to put this into exponential form. Yeah, I can go back. So you want to put that one into exponential form. And I'm going to do that in just 1 second. Need to quit drinking energy drinks, y'all. Trying to stay woke. No problem. Okay. So rewrite into exponential form. So remember, the circle of life works for exponential and it works for log. So you always want to start at your base, go to your outside, and finish at the other number. So for instance, start at 0.79, go to your outside, finish here. Okay. So this is going to be 0.79 raised to the t power equals c of t divided by 32,500. I know I made that look super easy. Okay, so always start at your base. Your base is the b term. So if you wrote this out in log form, this is how your log is normally written out. So b is your base. It's that number that's like itty bitty right beside log. Oh, wow. Okay, so sorry, I keep getting remind stuff while I'm doing this. So reading messages while I'm doing this. Okay, so now what I'm going to do is I'm going to multiply both sides by that 32,500. Then multiply both sides by 32,500. So this is going to look like 32,500 times 0.79 raised to the t. No, you can't multiply those two together, equals c of t. So you're going to leave it written like that. That is your final answer.
Will that be on the final?
Oh, yeah.
Okay.
And if you want some more practice, AKS 51 midterm is still open. So probably a good idea to go practice that.
What'd you do again? Sorry.
You're fine. All right, so I did the circle of life. Do we got that?
Mm-hmm.
Yes, I got the circle of life.
Okay, so then I'm going to multiply by 32,500 to the other side so that I can get rid of it in the bottom one. Yes is the last one, Chloe. Praise Jesus is the last one. Okay, so a few things I want to tell you. Is there anything else that aren't going over going to be on the final, or are you covering? Okay, so I'm going to go back to my first screen that I had because I think a couple of y'all missed it. Bye, Chloe. All right, so these are the AKS that are on the final exam. I think I covered 8. I covered 17, I covered 20, I covered 34, 42, 24, 51, 19. Only one I did not cover was AKS 6. And that's only because I opened it up 2 days ago. And I mean, I can go over those questions if you absolutely need me to. But it's kind of just like a identify what the variable is kind of questions. I can pull some questions if you need me to. Each one of these AKS, and I hope I'm not misspeaking. 1, 2, 3, 4, 5, 6, 7, 8, 9. Each of these AKS have 2 questions. Okay, so each one of these has 2 questions. So there are 18 multiple choice questions. There's 9 AKS. Okay, so if you want some extra practice, those midterms are still open, so you can still do it. Bye, baby. Okay, so just keep that in mind. Okay, as well as I think Khan Academy still has some stuff too. I'm gonna hit stop recording so we can like have a conversation.
Will survey and experimental and observation be on?